So.
All right. So how's everyone doing? I think I talked to about 3/4 of you already, but that's fine. So this is a little talk about together called Memory First, an Introduction to Redis. Probably should start this talk by asking the most important question, which is, who here has used Redis? Quick show of hands. Are you adjusting? You're adjusting the light. You're not saying. You're adjusting the light. You're not Redis ignorant. Okay. Okay. So a couple of you used it. What have you used it for?
It was some. I can't remember. It was years ago. It was some sort of website caching.
Yeah, caching. Yeah. I'm guessing that's true for you as well?
No, we used it to store counters across multiple machines.
Oh, nice, nice. So usually when I ask this question, you get an audience full of people, they all raise their hand. Like half the audience raises their hand. We got two tonight out of a smaller than large audience, but this is going to be a quality, intimate question. The nice thing with the small group is that you can just interrupt me, ask questions. We don't have to wait to the end. So, and usually I'll say, who's used Redis? And a lot of people raise their hand. And then I say, what do you use? Who's used it for something? Use it as a cache, and everyone leaves their hand up. Who's used it for anything other than a cache? And then almost all of them go down. And there's like 3 people in the audience of like 200 that have used it for something other than cache. And it's almost always as pub sub. So if you've used Redis, and you've used it as a cache, part of the goal of this is this is just a straight up introduction to Redis if you don't know what it is. So for all the users that didn't raise, all of you all who did not raise your hand, this is the perfect talk for you. There are good bits here if you have used Redis as well. I go into some details that you don't normally go into. So there's crunchy bits as well. But one of the things people think of Redis is they think of it as a cache. Redis can be more than a cache. It can be your primary database. And so I'm going to talk about that a little bit. I'm going to talk about just what it is and why you should care. My name is, oh, come on. There we go. Now my pointer's working. My name is Guy Royce. I'm a developer advocate at Redis, which means that my job is to come out to events and say Redis rah, 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 which is part of what I'm doing tonight. But a part of that job is also taking feedback from people who have used Redis and taking that to the product team and saying, hey, our users are saying we want this. And so there's a bit of a promotional aspect to what I do. Thank you for letting me use your venue to plug my corporate product. It's free. You can use it for free. So I'm not making any money if you use it for free, which is fine. But it's also, and I really think this is the more important part of the job, is taking that feedback back to the product team and saying, this is what users are saying and what they want. So that's what I do. You can see me there on, oh God, I've been saying Twitter for too long. I don't want to say X, but I'm going to say X. X is going to give it to you. This is my account on X. If you still use that platform, you can give me a follow. I'm trying to get my follow counter above 4K. I'm at like 3989 or something like that. So if each of you follows me, I will hit 4K. So the URL that really matters on here, honestly, okay, I thought the mic move. Is this one right here, github.com/Guy Royce. So I've got a bunch of sample code in here showing how to use Redis from .NET, the one that you probably care about. JavaScript, one that's probably some of you might care about anyhow. Java, which I'm guessing probably none of you care about. and Python, which you may very well care about because that's popular with all the data science stuff. So I've got examples, code examples in all those languages, and my slides are out there too, newly updated. So that URL is helpful. And I've got a link to my website there, mostly because I just want to brag that I've got guy.dev as a domain name. So, but you can find me on there. My email is guy@guy.dev if you want to email me and have questions.
Question.
Yeah.
So there's another account. There's you, and then there's another one. It's just your beard.
Yes, that is correct. Someone created an account called Guy Royce's Beard. It's been fairly inactive of late. I think it's because my beard's getting grayer and older, and it just doesn't really have as much to say as it used to. It's getting tired, wears out easily. Follow them both, sure, why not? I don't have any control over Guy Royce's Beard, that Twitter account, but it is out there. So, enough about me. Let's talk about Redis. So I like this thing. I like to say, what's a Redis? Redis is a product. It actually stands for Remote Dictionary Server. there's a little bit of trivia for you. Redis is often used as a cache. So when you ask this question, people say it's a cache. I use it as a cache. It's a key value store. This means that I put things in keys, just named keys, and get the values out. It's like a giant hash table or a giant collection. A lot of people say Redis is a message broker. It's got a pub-sub capability which lets you post messages and publish them out to a bunch of listeners. It's actually got a lot of capabilities. But what I like to say to sort of sum up the core thing that Redis is that it's a memory-first NoSQL database. And so that sounds like a nice, pithy, elevator pitchy kind of thing to say, but what does that really mean, right? What does memory-first NoSQL database mean? Well, it's memory first because everything in Redis is stored in memory. This is why it gets used as a cache so much. It's all in RAM. Now, it can also be persisted to disk, but it's in memory first and disk second. And so that means it's just screaming fast. When you shove things into Redis, you get millisecond response times or microsecond response times. You spend more time on network latency than you do on talking to Redis because it's just writing to RAM and reading from RAM. So it's wicked fast. It's NoSQL because you don't interact with Redis by doing select star from users where clue greater than 0. 0 rows returned. Instead, it's a key value store, and those keys contain all those data structures that you learned about in computer science class, in that data structures class you took at university that you've since forgotten. You know, the hash tables, the linked lists, the sets, just blobs of data. The Redis stores these data structures. I actually think this is Redis's coolest feature because it's the same metaphor that I'm using in my code. So in my code, I have a hash table or a collection or whatever you want to call that hash table. .NET, it's a collection. Or no, it's a dictionary. Sorry, a dictionary, not a collection. And Redis will store a dictionary as a hash table. And so I can read it out, and I get a dictionary out. And so it's speaking my language. There's not an impedance mismatch. I don't need to do like object relationship mapping with Redis because Redis is already in data structures that my programming language is like. So it's got linked lists, that's a collection. It's got hash maps, those are dictionaries, etc. And so I think this is actually its coolest feature. And it's a database. And so it's persistible. It will write out to disk, and you will not lose your data just because it's in memory. It is clusterable, so you can scale it up and smear your data across multiple servers horizontally. And it's replicatable, so you can create duplication across the cluster. So if one of the nodes goes down, you don't lose the data that's in that node. So it does all the things that a database does. Internally, Redis is a giant hash table. And at the heart of the hash table are keys. And those keys can have all kinds of data structures, which I mentioned earlier. The most basic one is the string. The string is kind of a misnomer here. It's not really a string. It's a blob. You can put a simple string, ASCII encoded, UTF-8 encoded, in Redis. It'll be perfectly happy to take that, but it doesn't actually know what encoding is. It's just storing the bytes. And so these strings can actually be images. So you could take like all the data in a JPEG and shove it into a string in Redis. So it's just a chunk of memory associated with a key. It's the most basic idea. It's a key and a value. You can riff on these strings a little bit. Because they are just blocks of memory, and they can be binary, or they can be text, or they can be whatever, you can treat them as bitmaps. A bitmap lets you do operations where you can say, go out and in position 17, flip this bit. And so if it's a 1, make it a 0. If it's a 0, make it a 1. So you can do bit level manipulation. You can do ands and ors and nots. You can take two strings and and them together. So you can treat this data as binary information and manipulate it that way. There's bit fields. This is another thing you can do with a string. I think this one's kind of neat. It, again, is treating your data in a string as binary information as opposed to text. But in here, you can do things like, okay, so I've got this block of data. Go to position 13 in this block of data, or position 97, or wherever, who cares, and give me the unsigned 13-bit integer. And it will pull out a number. And so you can do arbitrarily sized integer extraction and modification in these strings. And so you can say, you can modify them that way, and you can read them that way, which is kind of cool. I used this to solve a advent of code problem one year, which was a lot of fun. Because I had this weird low-level binary protocol where the first 3 bits told you that it was this type of record, or told you the type of record it was. And so you could pull those 3 bits out and get a number, and then do an if statement, and then use a state machine to just move your way through the data. So those are strings. Redis has hash tables. We just call them hashes. These are your basic key value pairs. The key is a string, or the field is a string, and the value is a string. And they are in a key in Redis. And so Redis is a giant hash table, and there's a hash table type that you can put in that giant hash table. This always begs a particular question, which is, can I put hashes inside my hash table? No, you can't. It's flat. You only get that one extra level. But they're fast. Accessing values in a hash table are O of 1 operations, and so this is a very popular structure. This is a good way to represent a record in a database. It just is as a hash. Yeah?
Can you do like individual modifications to that? So say if you look to bytes key and then change C to bar.
Yes, absolutely. So there are a whole series of commands for all of these data structures that will let you manipulate them all sorts of ways. I mean, strings have some very simple commands like get and set to get and set the string. Bitmaps operate on those strings, and there's a whole series of commands for those. On hashes, you can do like an hgetall, which would return just all the fields and their values. Or you could do an hkeys, which would just return all the key names. Or you can do an hget and give it a field name, and then it would return just that one field, and an hset on just one field. And some of the commands are variadic, so you can set multiple fields at once. So I'll be brazen and say that there's a command for almost every permutation of a thing that you would want to do against a hash table in Redis for working with hash tables. And if there's one missing, let me know, and I'll see about getting it out of the product, because that could be useful. So yeah, you can manipulate these things at an individual level. You've got lists. These are doubly linked lists, and so you can do you can walk those lists. You can get you can pop things off the head or the tail of the list. You can push things to the head or tail of the list. It's a classic doubly linked list like you learned about in data structures class. And there's a bunch of commands for manipulating those as well.
So,
yeah.
Is it one key the whole of the hash, or is it?
Yeah, there's one key that contains it. One key contains a hash table.
The entire hash table.
Yeah, and that hash table could have 10 fields. It could have one field. It could have a million fields, actually.
Yeah. And it's more than not just a JSON object. It's actually inside.
Right.
Redis as a thing that you can.
Yeah. And actually, behind the scenes, what Redis will do is it has a couple different data structures that we use to represent a hash table or represent a hash. And when they grow beyond a certain size, it'll swap to one that's more efficient. And you can even configure the threshold for doing that in the redis.config file and everything. So there's a lot of control. Same thing with the lists. A lot of these things will use different data structures depending on the size of them for performance.
So it's a hash table within a hash table.
Yo, dog. Yeah, you got it. And that's why the first question everyone has is, can I put a hash table inside of that hash table? And the answer is no, because
Yeah.
yeah.
Wouldn't be. Yeah. You can store more data inside.
Yeah. The field names are strings, and the fields themselves are strings, and the keys actually are strings as well. And you might remember that I said strings can be binary. So this actually means that you could have a hash table with binary data. Even the key could be binary if you want to live your life that way. I don't know why you would want to have a key be binary or a field name be binary, but maybe there's a good reason. Maybe you're dealing with mainframe data and it's EBCDIC instead of ASCII, and that matters or something. And the same thing for the list. You've got a key, and that key contains a doubly linked list. We've got sets. So sets are exactly what you think they are. They're that that thing that you can make Venn diagrams out of. My favorite, well, I'm not going to say my favorite Venn diagram because I'm being recorded, but we'll talk about that at the pub later. But like, you got zombies, and you see the T-shirts with like the 3 Venn diagrams of the intersection. It's those sorts of sets, and so you can add strings. It contains strings, just like the list does, just like the hashes do, just like the strings themselves are. But there's not any duplicated entries, and so if you add the string foo to it multiple times, it's just a set with one thing, the string foo. And then you can take multiple sets and do intersections and unions and all sorts of operations against them. There's sorted sets. These are like these are just like sets, but they have a numeric value associated with them, and so they have an intrinsic sorting to them because they have a rank. These are great for doing like in video games. You can do like leaderboards with these, and so you just put everyone's score in there, and then there's lots of commands to say, well, give me this person, this member of the set, and then things on either side of it, or give me the top 10 or the bottom 10. And you can do unions and intersections on sorted sets as well. And fun fact, if you do unions, if you do a union on a sorted set and they both have numbers but they're different values, you can specify what to do with the numbers, which is take the greatest or add them together, or take the smallest one. So you can actually do addition with sorted sets, which is kind of useless but fun. We've got geosets. In a geoset, it's just a sorted set where that numeric value is a geo hash of a particular point on the globe. So you can give it a latitude and longitude, and then each of the items that set represents a named thing, a member that's at a particular location, and then you can do various queries to say, show me all the things that are within a radius of this point, or that are in this set, or show me things that are in a particular fence. Hyperlog log is a little unusual. It's a probabilistic data structure. I have an entire talk on that, and it's a huge topic. Probabilistic data structures act like sets, but they are lossy. They lose data. They lie to you sometimes, and they give you inaccurate results. But you can do things like a hyperlog log can hold a number of, it's all about getting the cardinality of a set, the number of unique items. And you can add like a number of unique items to a hyperlog log, like equal to the number of atoms in the universe, that kind of level of thing. And it will never be more than 12 kilobytes. And it will be like 90, I think like 90 some odd % accurate. And so depending on what you're doing, maybe 95% accuracy is perfectly acceptable, and then a hyperlog log would be useful. Say you're counting unique visitors to a YouTube video or something like that. It's like once you get up to 1 billion views, does it really matter how precise that number is? Losing a little bit of accuracy is totally fine. So use them for those sorts of things. And then last but certainly not least, and there actually is more to Redis than this, but these are a lot of the big ones. We've got event streams. So if you've used Kafka, you know what an event stream is. You can think of them as a log file. This thing happened at this point in time, and here are data values associated with it. And this thing happened after it, and this thing happened after it. So it's an ordered set of events with a timestamp associated with them. We're not going to talk about that in detail. That's a big topic as well. But if you are using event streams for something, if you find you need to use event streams and you're using Redis already, it's there. Have at it. I actually have a talk where I do called Tracking Aircraft with Redis and Software-Defined Radio, where I take aircraft transponder information, broadcast off the aircraft themselves through a radio, and then I take the data off the radio and I shove all the transponder messages from the aircraft into an event stream. And so you get several of these, the aircraft are often emitting several of these a second, hundreds a second. And just fill up that event stream, and then I can use that to do all sorts of things. The structures we're going to talk about today are the 4 basic ones: strings, hashes, lists, and sets. So that's what Redis is. But Redis can be more. Redis is extensible. It has a capability called modules. It's a sort of a plugin framework where you can write your own custom extensions that can add new commands to Redis and new data structures. And so if you wanted to say have a command that returns the date time, you could write a date time command. Actually, there might be one that does that already. But you could write a command of your own that does whatever you want. You want to create a new data structure, you can do that. Maybe you want to create like a, I don't know, B tree or something. You could do that. Redis has created several of these themselves. We've got one to add JSON, so you can have a JSON data structure in Redis, which is a pretty obvious one. I'm guessing all of us would deal with JSON on a regular basis. We've got one for search. One of the things that Redis kind of lacks in its core functionality is the ability to search for things in Redis, because it's just a key value store, so you have to know the key that the thing is in. Redis search will allow you to index hashes and JSON documents so you can find the ones that you want. And so you can do queries against them and say, give me all of the Bigfoot sightings that happen in Ohio. That's another topic that I like to do talks on is Bigfoot. And so search can do that. It actually has a vector search capability in it as well, because everyone's got vector search now, and so do we. It's actually pretty cool. But we're not going to talk about that tonight either, other than to mention that it exists. We got balloon filters. These are other probabilistic data structures like hyperlog log, other than hyperlog log. Balloon filter, some of you may have heard of balloon filters. That's what is one of those data structures. It's got a top K structure. There's several of them in there that do the same probabilistic thing where they are accurate enough, but sometimes they lie to you. But they're true enough that you can do useful things. And there's a time series data structure as well that we've created. So if you've got, say, like weather information or stock ticker information or any like telemetry kind of stuff, you can use a time series for that. And we've bundled all these things together into a thing called Redis Stack, which you can download, which is what I'm going to be running tonight. The plan is to roll this into Redis Community Edition when that comes out, but that's not out yet. So for now, Redis Stack is the way to get all these things. This is basically just the Redis that I just described with JSON, search, Bloom, and time series baked into it. So you can just download it as one. I just use Docker, or you can use the cloud. And if you use the Docker version, it actually comes with a nice GUI baked in called Redis Insight. And you just point your browser at it and it works. You can also download and install Redis Insight on your own. It's in the App Store, it's in the Windows Store, and I'll be using it tonight. And there's the URL. So this is the ad slide. You go to redis.ir/try-free, and you can sign up for a cloud account, or you can go to Docker and get the Redis Stack image. I'm using Redis Stack because I never want to count on Wi-Fi when I'm giving a talk, so I'm using Docker. But when I go to build something real, I do it in the cloud. So that's a lot of what Redis can do. I've talked a lot about capabilities, but I haven't gotten real yet. So we're gonna dive down another layer and get into more what this thing really does. And so how do I talk to Redis? How do I actually get it to do things? Well, there's a whole series of commands, and you send a command and you get a response back. It's just kind of like talking to a relational database or any other database. And so if I send the command ping over the wire to Redis, it will respond with Pong. Makes sense, right? If I send time, I knew there was a time command. It will respond with the epoch in seconds, so that'll be seconds since 1970, and then the microseconds within that. So that'll give you an array of values back with those two values. And if you send the flush all command, any guess what this will do? What's that?
Empty.
Any idea what it returns? It just does it. So don't ever let me touch your production Redis, because I build a lot of demoware because I'm a developer advocate, and I have little toy instances of Redis running all the time, and I wipe them out all the time with flush all, and yeah, it doesn't ask. Now you can lock down Redis with secure permissions and ACLs and stuff, so that command is not available to everyone. So, and that is highly recommended. Now you send a command, you get a response. The commands are sent over a protocol called RESP, which I can never remember what it stands for, but it's called RESP. This is the wire protocol that Redis uses. The client library is written in languages like JavaScript and Python and .NET and Java and Go. This is the protocol they use to talk to Redis. And it's not terribly complicated. So if I want to send the command set, this is going to set a key in Redis, sets a string. I'm going to do message of the day, and the value is greetings. Here's what it sends over the wire. It sends *3, carriage return line feed. It's very Windows friendly that way. The *3 means I'm going to send you 3 arguments. Whoops. Then it says $3. The first argument is a string. That's what the $. Means. Anyone remember doing a line number basic on like the Commodore 64 or the VIC-20? And you define your variables like $1 as a string? It's a little callback to that. So $3 means it's a string, and it has 3 characters, or 3 bytes. Those bytes are set. And then $4, it's string, it's 4. $10, it's string, it's 10. And so this is the command that gets sent over the wire. And it responds back in kind. So it responds back with, here, plus OK. Plus means it's an embedded string, which is internally in Redis, some strings are, this is a simplification, it's wrong, but it's close enough. And none of us are going to look at the C code for Redis anyhow, so it doesn't matter. Plus you can think of as being on the stack versus being on the heap, although that's not really true because they're strings. But Redis has like 2 different layers of memory, and the stuff that has a plus are, in essence, all the hard-coded strings are the really small ones. When they get bigger, they use $signs to represent them. So OK is a common response, so it just says plus OK. And that just gets returned on our client library to say, OK. Here, we're going to get the string, and it does the same sort of transmogrification. And then it returns here, the word greetings is not an embedded string, it's a raw string, and so it's got the $sign in. So when it comes back, it puts a little $10. It says, I'm responding to you with a string that's 10 characters. And here it is. And then you get the string greetings back. So this is the underlying wire protocol. So if you've used Redis before, this is one of those bits where you probably didn't know this. Now, this isn't really super complicated. And I had a coworker that used to do a talk where he would live code a Python client for Redis that would parse this protocol. But it's not super hard. And in fact, we can use this protocol from the command line and show that this is real. So I've got Redis running on my machine. Let's go to here. So here I've got Docker. You see I've got Redis stack running right here. So I'm just running it in Docker. And if I go to the terminal here, I'm going to do netcat -cv. So is that big enough? Is the font big enough for everyone in the back row? Okay. So netcat -c means send a carriage return line feed whenever I hit enter. And -v just is verbose. And then we're going to go to localhost. And we're going to go to 6379, which is the port Redis listens on. I'm going to hit enter. And we have now connected to Redis. It's very exciting. So I'm going to send a ping command. So if I say $1, I'm going to send you 1 argument. Sorry, I said the wrong thing. It's a *1. My typing is correct. My words are lying. And I've hit $4. I'm going to send you a 4-character string, and I'm going to send you ping. And response with pong. And I do a $1 or *1, $4, and then quit. That tells Redis I'm done with the session and you should close the connection. It says OK, and it returns me back. So you can talk to Redis at the lowest level. Now, do you want to talk to Redis this way? Of course not. But you can actually test the lowest level protocol this way. It's kind of fun.
It seems why does it have to say, why can't it just parse the string with the command? Rather than you have to say, there's 3 characters coming and then there's another. Yeah, it's 3 characters. Just parse it.
So when Salvatore wrote Redis, I feel you. When Salvatore wrote Redis, I think he was trying to strike a balance between something that would be relatively human readable, because this is human readable, but it's not a protobuf, for example, right? But at the same time was easy to parse so that the code on the back end could be easier. I think he's trying to move some of the burden to the client libraries, as opposed to having to parse strings on the back end all the time, because that can get really hairy. That's all supposition, right? My real answer to that question is I don't know. That's how it works.
But there are some cases where you want to send spaces and so you
Yeah.
use a space.
Well, there's a few others as well, so on the target, look at certain sides, it's not good.
I suppose it means you don't have to put quotes around the
If-
string.
Yeah.
If you wanted to send a key of quote space, it works quite nicely.
Yeah. Now, there is a command line tool called Redis-CLI, which will let you do ping. And so then you just type and it works. And so I can literally do, like if you pass something to the ping commands, it will respond with whatever you ping it with. And if you want quotes in there, you can do things like this. Or you can escape it with a backslashes. It's fair, but this is all happening in Redis CLI, which is a command line tool to interact with Redis. Redis itself, if we were to look at the wire protocol, is sending the quote like you said. So I think he did it, again, speculating and sort of conversing here, is just because it was easier to parse on the back end. And a lot of what Redis is doing is trying to be simple and fast.
If you want to be fast, it's better if you don't have to parse it.
Right.
I guess it means you can have weird quotes and having to worry about
Yeah.
escaping.
Well, and these strings can contain binary data too, which I guess I've got the thing going here. I might as well do the binary data demo while I'm here because it's kind of fun. So let's go into here. So I've got a picture of Elvis here, which always makes me laugh. And I'm gonna shove this into Redis just to show that strings contain binary data, and also just to show what that looks like. This is a little ahead in my demo, but
Dolly or
it's sort of like a Dolly.
version of
Dolly meets Starry Night. It's like Super Starry Night, yeah. I'm going to say Redis-CLI. So Redis-CLI, in addition to running it and getting a little prompt, you can also send commands to it. So I can do like Redis-CLI ping, and then it will just run it, which is real handy for scripting things. But I'm going to set Elvis, and then I can do a -x. And what -x says is, and then whatever's piped in at the end, make that the rest of the command. And actually, I want to do it over here. I don't think the order matters, but I'm not positive. So this will say set Elvis to whatever bytes I get pushed in from the command line. Make sense? Hit enter, and it just works. And if I do Redis CLI get Elvis, this is what you get back. So in Redis, it's just storing bytes. But when it encodes it across Redis CLI, it's doing /x to like here we got /x64, so that's byte hex 64, that location. But the next one just happens to be the letter R, and so it just shows you the letter R. But if you go into Redis Insight, which is this little GUI tool, and actually look at, let's refresh my keys here. There we go. Click on the string. You can see it's clearly got binary data in it because it doesn't know what to do with it. So that REST protocol is just saying, Redis CLI is just getting all the bytes that came in. It's literally saying $, however many bytes there are, and then sending them in raw. So let's see. What do I got next here? Yeah, so this is where I got a little bit ahead of myself. So strings, I mentioned you can use set and get to get strings. It's not very complicated. I mean, set foo bar, get foo. And those strings can be stored different ways. Here's the command I just did with a binary file. I did it with the Elvis image. So if you want to put binary data in there, that's one way to do it. You can also do it programmatically with the client libraries, and they have various mechanisms depending on the tech stack. But strings can also be set to be numbers. There's inker commands and inker by commands, or inkerby, as I like to pronounce it. And so Redis, these ones here are stored as either raw or embedded strings, depending on how long they are. But the integer, if you actually set a numeric value in there, stores it as an integer behind the scenes. And so the strings can also be integers. And this can be more useful than you think, because that hash table that is everything that is the data in Redis is behind a single thread. So nothing else can happen when something is happening. It's kind of like JavaScript that way, or Windows 3.1. And so if you call inker on a key that doesn't exist, it sets it to 1 and returns it. If you call it again, you get a 2. Call it again, you get a 3. And so if you wanted to create serial numbers atomically, you could do that. And if I could demo this, yeah, let's go ahead and demo it real quick, just to show how these strings kind of work. So we've done the binary bit already here. Okay, there we go. So Redis-CLI. And if I do object encoding Elvis, comes back and says raw. It's a raw string. If I set a small string, say set foo to bar, and I call object encoding on foo, it says it's an embedded string. And if I do a set sum number to 42, and I ask for the encoding on sum number, it comes back as an integer. So under the covers, these are different data structures. In fact, if you use the object encoding command on like a hash table, it will tell you which hash data thing it's using. So there's a lot going on behind the scenes. Where are my slides at? Here we go. So I always like, is it there? There we go. So I always throw this up here. So this is perhaps the most important URL if you want to use Redis that you will ever see. This is the entire reference documentation for every command that Redis has. So if you want to figure out all the various things you can use the set command to do and all of its various arguments and various ways of using it, this will tell you. If you want to know every command for dealing with hashes, this will tell you. I work for Redis. I've worked for Redis for about 4.5 years, and I probably go to this site every day. I didn't go to it today because I was on a train, but but I go to it very often. And so, if you take one thing away from this talk, it's that site is useful if you're going to use Redis. So you can set keys, you can get keys. There's the underlying protocol. There's all these data structures. Redis gets used as a cache a lot, and one of the reasons it gets used as a cache a lot is because keys can be persistent or volatile. So by default, if you set a string in Redis, it's persistent. It'll stick around in memory forever. If you've got persistence to disk set up, it'll stick around after you shut down Redis and bring it back up. If you've got it turned off, it won't. They stick around until you delete them, until you remove them. Volatile keys are given a time to live. They have an expiration date, after which point they will be removed. Redis will do this for you automatically, and so you don't have to do anything. So this makes it fantastic for caching. If you've got some API that you're calling, say to get the weather for a particular area, and the weather doesn't change that often, but the API costs money, you can hit that API, get that weather data, and then everyone in that county that wants to get the weather forecast, or in that city that wants to get that weather forecast, they can be handed the same one. You don't have to hit that API multiple times. It's fairly straightforward. Here I am setting foo to alpha. That is now a persistent key. It is safe. It is not going anywhere. If I want to make it non-persistent, if I want to make it volatile, I can give it an expiration and say, expire in 3,600 seconds. So stick around for an hour. Or I can say expire at a particular time. Now, Redis behind the scenes may not necessarily expire it right at that moment. It's got a background processes that will check periodically, but because it's single-threaded, it doesn't want to spend time keeping that thread locked down necessarily doing this. And so sometimes it'll stick around longer than you want, but it'll never stick around less time than you want. And if you go and try and query it, it'll look at the time and say, oh, this should be gone, and then it will delete it then, and it won't return it to you. So the experience will be that it's gone, even though it might actually be sticking around in memory still. You can query the time to live with the TTL command, or you can get the expiration time with the expire time command. And there are microsecond versions of all these commands as well. And if you decide that a key is volatile and you don't want it to be volatile anymore, you can call persist, and then it gets rid of its time to live. The set command has options on it so that you can set a command and its time to live in one command. So you can just, one command comes in atomically and does that thing. So you can do that all in one step. I'm going to skip the demo of this because I'm probably going a little long, and honestly, it'd just be me typing more commands into Redis. You can try them out yourselves and see that they work. Here's some commands for dealing with lists, sets, and hashes. So lists are just doubly linked lists, and so you have commands like lpush to push things to the left side of a list, or rpop to pop things from the right side of the list. And you can push on the left, push on the right, pop on the left, pop on the right. You can push multiple things in one command, so you can say lpush foo, alpha bravo charlie. However, it's worth noting that it's going to push alpha to the left side, and then it's going to push bravo to the left side, and then it's going to push charlie to the left side. And so if you get your entire contents of your list using the lrange command, it will be charlie bravo alpha, because it's just pushing them in the order that you give them. There's set commands for sets. I mentioned earlier, we like pronouncing the commands at Redis because some of them are funny. And this is one of the funny ones. You got the sad command. It's the loneliest of all Redis commands. It's the set add command. And so here we're adding alpha bravo charlie to a set. You've got the s is member. Is alpha a member of the set? And it will return 1 or 0, whether it is or it isn't. Or as I like to call it, the sys member. You've got the s members command, which will give you all the members of a set, or the smembers command. And then we got the s union, which will union a couple sets together. There's also an s inter for getting an intersection, and an s diff for getting the difference of sets. I used to pronounce s union as sunyon or sun ion, but I thought sunyon was funnier. And s inter is sinter, of course. And then if you're working with hash tables, you've got like hset, and you can say set in the key foo the field alpha to the value of a. And then you can get in the key foo the field alpha, and then it will give you just that one value. Or you can do an hgetall on the key, and it will give you all the keys and all the values. So lots of commands to manipulate these basic data structures. There's a couple interesting ones. Hashes can get really big. You may do something where you have a hash that has 100,000 entries in it. Sometimes that makes sense. If you said hgetall, Redis would dutifully go out there and walk that entire hash tree or hash table and hand you every key name and value, all 100,000 of them. And while it's busy doing that, that single thread will not be doing anything else, which can lock out other users. And so there's a command on Redis called hscan, where you can go and get a page of it and get another page and get another page over multiple commands so you don't lock Redis up. So there's commands like that as well. I'm going to skip demoing these as well. And I'm going to talk a little bit about one of the modules very briefly, which is JSON, because honestly this is, JSON is a list, JSON is a hash, because it's a tree, right? And lots of times you're doing stuff with JSON. So Redis has a JSON module, and it solves an important thing. So this is sort of a simple scenario that can happen if you're storing JSON in a string, which is a common solution. I've got a JSON that I get back, I want to store it as a string. I've got some object, I've serialized it to JSON, I want to store it in Redis. So I set foo to some JSON string, and then I want to modify it. I want to change something on object. So I load up the object, I read the Redis, I parse the JSON, I make my change, and then write it back out to Redis. Anyone see the risk of this? Right there? Where is this working here? It's totally not. Yeah, when that parse string happens, someone else could come in. You got a race condition. Someone else could come in and read that same object, and before you've written it back out, and now they've got the wrong version. This is the danger zone. I did a talk one time, a version of this, and I had a picture of Kenny Loggins' Danger Zone album on there. But anyhow, but this is a problem, right? Because you could step on each other. JSON, the JSON data type solves this by allowing me to manipulate the JSON at an individual level. So instead of having to read the entire JSON string and parse it on my side, I send the JSON string into Redis, and then it parses it into a tree, and then I issue commands to query and modify that tree, and each command is atomic. So here I'm setting a simple string of foo to the root of the JSON document. It's got bar alpha. And then I can say JSON.get from this, what's in foo, $.bar, and that will just return the string alpha. Yes, sir?
What happens if you're trying to target like an item in an array? So say you've got a person with a bunch of addresses.
I have a demo for that. I am going to show that demo. So it's full JSON path syntax. So if you've done any JSON path querying of anything, all of that works. And so you can put square brackets and star, or say give me the first thing, or give me, like the JSON path array queries will even say let you get like the last two items in a list. There's lots of ways of slicing and dicing it, and they'll all work. And so here I can set the entire string. I can get $.bar, but I can also call JSON.setFoo, give that JSON path and modify it in the same way. And this modification doesn't require me to load it all back, parse it, change it, write it all back as a string. I can send just this single command to Redis to make that modification. And I do have a little demo for this, just to kind of show it off here. So let's go back to here, exit. So, and if I go into here, let's do Redis CLI, flush all. There we go. See, I told you it just returns OK. And I've got a little sample JSON here. And that's what it looks like. It's got a single contact for Elvis Presley, age 42. That is actually his home in Tupelo, Mississippi. It wasn't named Elvis Presley Drive when he was born there. They did that later. And then I've given him a couple of phone numbers, which are totally made up, but are in the correct area code in the United States. So this is a simple little JSON document. And so I'm going to shove it into Redis. I'm going to say JSON.set. We'll call this Elvis as well. Since I flushed the database, there's nothing in there. It doesn't have the image anymore. And so I'm going to say JSON.set, key name Elvis, in the root, and then -x. And then we'll just shove the sample.json in there. And I think I did that right. Yeah. So now if we go into Redis Insight here and refresh our strings, we'll see we've got a JSON named Elvis. And you can see there's actually a JSON data structure in here that I can expand and look at all the values in. So it's kind of cool in its own right. I can actually go in and just manipulate all these in this GUI if I want. I don't want to do that. I want to do it the hardcore command line way.
Will it return an error if it's not proper JSON?
What's that?
If you've missed a bracket or something in your JSON string, will it return?
It should complain and say it's not valid JSON. Let's try it really quick. Redis-CLI, JSON.set, foo. And not put that. I don't know if Bob the Builder's a thing over here or not, but it certainly was in the US when my kids were younger. It actually says it's the wrong number of arguments, so it knows that that's incorrect. Let's make sure.
You miss out the
Actually, no. I'm stupid. We should get a better error message. And if I were parsing a string at line 1, column 19. So that makes more sense. If I put put that in there, now it says OK. So it'll catch invalid JSON. If I want to get the Elvis string, though, JSON.get Elvis. If I just do JSON.get Elvis and pipe that into JQ, if you've never used JQ, it's it's like sed for JSON documents. It's amazing. And here it just returns the document. So I just queried the whole JSON. Not a huge deal. But if I want to say do a path, so let's get the name out of it. Well, now I can query just the name. It's worth noting that it's an array. And the reason it's an array is because as soon as you specify a JSON path, there are that path could potentially match multiple places in the document. So it has to return an array. So for example, instead of getting the name, let's get the address. We'll start with the address just to show you that it'll return chunks of the document. But let's go to $.phone numbers. And pipe JQ. So that returns an array of arrays because the phone numbers is an array. But if I wanted to get actually just the phone numbers and not whether it's mobile or not, but just the number itself, I could say phone numbers sub star dot number. Whoops. What did I do wrong there? Oh, so there's a star in the command, and the command line picks that star and doesn't like it, so you got to put quotes around it. Because star means something special in the command from the command line. So that gives me just the phone number, an array of the phone numbers. And I could do stupid stuff like, let's change all the phone numbers. Instead of JSON.get, I could do JSON.set phone number to, and it's got to be a JSON string. So I got to put it in quotes. We'll do +1, I don't know, 601-555-9999. What did I do wrong there? It might not like the plus. I know that this will work. I'm doing something stupid and wrong. Let's try this.
Is it because you try to show it through JQ?
I bet you're right. Yeah. Yep. It's always, see, we're pair programming here, folks. And if we go out here and look in this document and look at the phone numbers, it's been set to the 9999 number in both of them. They've set to the same number. So you can actually do like things that match multiple queries or paths and set them all. So all kinds of stuff. It's anything you can do with JSON path you can do against Redis JSON, which I think is kind of cool. So what else do we got here? I got one other thing I want to demo, and then I got one other slide, and then we're pretty much done. Because I think you probably want to see actually, like we've seen lots of commands on how to interact with Redis, but how the hell do I put this in code? We want to see some actual code that does something. So I've got here, since this is a .NET meetup, I have a .NET example. If you are a JavaScript person, we have a JavaScript example out there as well. The libraries to talk to Redis for .NET is called Stack Exchange Redis. And if you want to do like JSON and that stuff, there's a secondary library called NRedis Stack. And it's broken into two things like that because the Stack Exchange Redis team works for Microsoft, and the NRedis Stack team works for Redis. Now, if you're a JavaScript node programmer, we have Node Redis, which is maintained by Redis. And so we just have one library that does all the stuff. And the same thing for Python, the same thing for, which is Redis Py, and the same thing for Java, which is Jedis. And we maintain a Go client as well, which I think it's just called Redis Go. I don't know, I'm not a Go developer, so I haven't looked at it at all. But this is Stack Exchange Redis, and this is just doing some basic sets. So here we bring in Stack Exchange Redis. I mean, this is a really basic project. I'm just, here I'm using, this is probably an old version of Stack Exchange Redis because I haven't updated it in a year. You create a connection multiplexer to Redis here in one line of code. There should only ever be one of these. What Stack Exchange Redis will do behind the scenes is it will take, in your process, multiple commands to Redis and multiplex them down to a single connection to Redis so that you can get as much utilization out of that one connection as possible. And then from there, you can call get database. And then on the DB var that you get back there, you can start doing commands. And so here, we call ping. So there's a function in Stack Exchange Redis called ping. And then it doesn't return Pong. What it does is it returns a response with the total number of milliseconds it took for that ping to happen. So it's measuring it for you, which is admittedly a little bit more useful than just returning Pong. Here I am doing a set and a get, so we call string set. And it's worth noting the function is string set. Behind the scenes, the command is set that's being executed. And if we look at the signature of this thing, I think this is kind of interesting. I'm passing simple colon string as my key name, and I'm passing in foo as my value, but it is Redis key and Redis value in the IntelliSense. And that is because that key name could be binary. It doesn't have to be a simple encoded string. And that value could be an integer, it could be binary, it could be bytes, it could be a string. And so that Redis value and that Redis key allow you to pass all those in. I'm passing in a simple string here, the value of foo, and then string get. You'll notice it returns a Redis value as well. Same thing. But this is as easy as it is to get inside a string. It will return a nil if there's not a value in that key. I am blithely ignoring that by putting a bang at the end of it. So judge me. But that's how you could get a simple string from .NET. Here is how if you just pass in a byte array, boom, you're passing in binary. And then if you go and get it, you can just assign it to bytes, and boom, you've got the bytes. So it's actually very easy to work with binary data in .NET using Stack Exchange Redis. Node Redis is a little trickier because you've got to use node buffers, and then you have to tell it you want a node buffer as opposed to a string coming back. If you want to set a number, you can just pass a number in, and if you want to get a number, it's very unintuitive to call string get and get a number back, but and you do have to cast it, but you can do it with a number as well. And then once you've done that, I've got various increment commands here. So string incr, string decrement, string get, and then and here I've got a couple other commands. There's an exist command that tells you whether there's a string in a key exists or not. So that tests if something exists or not. And there is a delete command, which is actually calling unlink behind the scenes, which is the preferred way to do it. And then here I'm setting up some key expiration. So I'm calling db.keyExpire. I give it a key name, and I give it a time span in seconds. And you can query the time to live. So there's just basically, and this is how most of the Redis clients work. There's a whole bunch of commands, and then there's just functions that map to those commands. And so that's why the Redis.io commands thing is so useful, because it tends to map one-to-one to the client libraries. Yeah?
On those keys, I presume that number colon string is just the name of the key. That it's not passing the fact that one's a number and one of them's a string or anything.
Correct. Yeah, correct.
You just call it a number colon string.
Yeah. So that's a convention in Redis, which you tend to create. Because it's just one giant hash table, you tend to use, we call it a key space notation. And so I'll go to my Bigfoot sightings example. If I have Bigfoot colon sightings colon and then ID number. And so then if I know my ID, I can just go read the key and then parse the data and spit it out. And then that guarantees I get unique keys. And so lots of times people just use GUIDs and that sort of stuff, or they'll use some sort of key space with a GUID. And so I'm kind of showing that convention here by saying number colon string. It's not a good example of it. But yeah, I'm just mimicking that convention of using colons to separate the key spaces.
exist command do anything different? To make it faster, or?
It basically tells you if the key exists or not. Sometimes you want to know if the key exists or not, because if you say get on an empty string, on a key that doesn't exist, it'll return an empty string. And if you, Redis doesn't differentiate between that. Like if you decrement a number to 0, it removes it, the string from Redis. And then if you say, you try and get the count of it, it'll return 0. And so it figures that kind of stuff out. I mean, I'm probably wrong on that point subtly, but let's go back here and I'll show you what I mean. Redis CLI. Let's do a flush all. And we'll do set foo and set foo alpha. And say exists foo returns 1. That key exists. If I say exists bar, it'll return 0. It doesn't exist. But if I say get bar, it should return nil. So sometimes you want to know if a thing exists or not. But if I do like hget bar alpha, it'll return nil, which doesn't mean that bar doesn't exist. It means that alpha doesn't exist in bar. But if bar doesn't exist, then alpha doesn't exist in it either. So it's really, really permissive. Like Redis commands will try to do what you meant as often as possible. So like if I do hset bar bravo 42, and I do hget bar alpha, it still returns nil, but exists bar is going to return 1. So the hash exists, but the field within it doesn't. Make sense? No. Good question. And yeah, so but, there's lots more commands here. We can go through this. I'm going to run it just to show that it's real. And so if I do .NET run, it'll go through, and there's the result of calling ping. Here I have set and get a string. Here I set and get binary. Here I set get some numbers and increment them. I do exist. I do del. So all this code's running and doing the things and saying what it found. If I go out to, I think I deleted everything. But if I go out to Redis Insight, we should see. There's our simple string. It's still out there. There's our hash. So we'll go back to, I got one final slide here. Well, a couple final slides, but this is the important one. I just wanted to mention persistence. I've said several times this can write out the disk. It totally can. There are two ways to do it. You can do a Redis database file, which is just a dump of what's in memory, a snapshot on disk. You can configure how often that happens in your Redis config. And so you can say every 3,600 seconds. So, every hour if at least one key has changed. And save everything if at least 100 keys have changed within 5 minutes. And if 10,000 keys have changed, save it every minute. And so you can set very specific thresholds. You can actually say, how much data am I willing to lose? If I have a single instance of Redis, you can explicitly configure it. And you can force this to save by calling save or BG save, which is background save, which is the better one. Save will just take a snapshot and lock up Redis while it writes it to disk. Background save will fork and write it to disk. So you almost always want BG save. The other option is an append-only file. The append-only file has to be turned on. It's not on by default. And what it does is it just appends all the commands that you send to Redis that would modify the state of Redis. And then you get a big log of all the things you've changed over time. And then when you spin Redis up, it replays them. And it will write these commands out to disk periodically. You can say, write it out every single time, which is to say, every single time a command comes in, write that command to disk. That makes Redis slow, and it's a bad idea. You can say, don't control the writing out to disk, and just let the operating system decide when to flush the file, which is risky, but efficient. And that's what happens if you set it to no. Or you can strike a balance and just say, every second, write out the append-only file. And then there's configuration settings for compacting this file. Because like if you set a string 10 times, the last set is the one that matters. you set a string 10 times and delete it, none of those commands need to be in the file at all because it's gone. And so you get a lot of churn in there. You can compact that file down a lot. So these are two ways of saving things to Redis, in Redis to disk. You can force the rewriting, the compaction of the append-only file with the rewrite AOF command or the background version of it. Any other questions before I show the QR code?
So that's a bit like the AOF is not like a database log.
Yeah.
Log file. That's like a database backup file. But usually what you do with database is you periodically back up and then you use the log.
And you can do both.
You want to recover. So could you do the same thing?
Absolutely. Yeah, you can configure both and set rules to make that all make sense. Yep. It's one of those things where the config file actually has a lot of, there's a lot of things you can configure in the config file. I mentioned how some of the data structures will swap out depending on how big they are. You can actually, there's config settings to say what that threshold is because you want to squeeze every last ounce out of Redis. There's lots of little things like that. Like Redis is normally operating over a socket, but you can use Unix pipes or Unix sockets. I always conflate named pipes and Unix sockets together. But if you're running, you can use Unix sockets instead to talk if Redis and your code are on the same machine. If you want to get rid of the network stack entirely because you need that much performance because you're running on like a Raspberry Pi or something, you can do that kind of stuff. And so there's lots of things you can tweak out in Redis when you download the code and just start messing with it. It's enough rope to shoot yourself in the foot.
If it's memory first,
Yeah.
is there a limit to how much we should put in it?
Generally, there's two answers to that question. One is more involved. The shortest answer is yes. Normally, you want to set a value for your max database size. And because Redis will just take it all, including swap space, which is bad. Because now you're on disk and defining the whole purpose of using a memory-first database. You can set that if you have a dedicated machine. I'd usually set it to be like around 75-80% of the available RAM. You can get away with that if Redis is the only thing on it. And keeping into account how many connections you want to have.
So the persistent side is just to persist the memory,
Right.
more than to store any more than.
Yeah. It won't roll. It all has to be in memory.
Grab
Yeah.
it, keep it all in memory.
Yeah. There are rules that you can set up for what happens when you try and give Redis more data than it's set to take. One is it just says, no, I'm not going to take anything. And there are various eviction rules to say, no, get rid of these things in this sort of order. So you can say, get rid of something that was going to expire soon anyhow. Or just get rid of a random key, we don't care. Get rid of something that hasn't been used lately. There's several options there for different eviction policies for when you try to feed Redis more than it's been configured to take.
So ultimately, it is cache.
Yeah. It's with the persistence options, you can use it as a database, and because you can cluster it, then you can fan that database off across, shard it across multiple nodes in a cluster, and that's a whole another topic.
Do you actually know it's in memory because it's virtual memory? It might be page to disk.
Well, and that's why setting the
There's a way of
that can happen.
You definitely want to use physical memory.
No, that's why you want to make sure you set your memory limitation in the config, because otherwise it'll do that, but
It'll start paging
and the operating system will do whatever it's going to do.
Yeah.
And our enterprise product that we sell in the cloud has a what we call auto tiering, where you can do like a Redis on flash sort of thing, where cooler keys that are used less frequently get put into flash, and then other are in DRAM, and then you get a tiered memory sort of structure. But if you're just like running this on your MacBook, you're not doing that, right?
This is really all about performance, isn't it?
Yeah, we have let me show you
As opposed to a database.
there's our marketing slide. See how fast feels. We actually, one of the products we have is a water bottle, like the piece of swag. It says "Taste the speed," which is kind of funny. But yeah, it's very much a performance play. I mean, it's real-time data. That's the thing that it really solves really, really well. And so it's obviously a fantastic cache, and Redis dominates in that space. but you can. It's more than just set a bunch of strings from API caching. There's lots of ways to cache that data, and even persist it and keep it safe outside of it. Other questions? Everyone's like, we're just ready to drink. My brain is full. Please make it stop. So here's a QR code that will take you to the repo with this very slide deck, which I just updated like a couple hours ago in my hotel room. All the code examples are out there, and you can play with this all yourself if you want to see that it's real. This QR code is safe. It'll never give you up or let you down or take you to some site that it's not supposed to. It actually goes where it's supposed to go. So if you want to scan that, then go ahead, and if not, then I'll just...
What you're saying sounds like it's going to end up with Rick Astley.
Gosh, why would... I have never rickrolled an audience. I wanted to do it so bad, but... So I just make a joke about it instead. So that's out there if you want it. And there's my contact information again. And that's what we got. See how fast feels, I guess. Thanks a lot.